Hi everyone, good day. We are the group 15 and 16, and today we will discuss two topics which is all about statistical analysis and calculations and the laboratory and data litigation. So I'm Beverly Lai A. Dizon, and I will explain to you the statistical analysis and calculations. Before we will go further on explaining the statistical analysis and calculations, we will first know what is the LIMS or the Laboratory Information Management System. Laboratory Information Management System, or LIMS, is a software solution to address the data management, automation, and regulatory challenges of laboratories across the globe. So, kaning LIMS, mauni siya ang mo-support in a modern laboratory's operations, and it provides detailed and accurate records of each sample and stores it securely. Mauning nakanay sa LIMS kay detailed and accurate jud ang result niya and masecure jud imong data. Thus, as a result, it is reducing the chances that data could get lost or mixed up as it moves between workers and departments. And by using a LIMS, your lab can automate workflows, integrate instruments, and manage samples and associated information. So, unsa di ay ang statistical analysis and calculations aning LIMS? Some of us here might not understand the meaning of statistical analysis and calculations, so ato asa ni silang i-define. What is statistical analysis? When we say statistical analysis, this is the science of collecting, exploring, and presenting large amounts of data to discover underlying patterns and trends. So, mauni siya ang pag-collect, pag-explore, and pag-present og mga dagko nga data. And what is calculation? It is a mathematical determination of the size or number of something or the studied care in analyzing or planning. So in other words, mauni siya ang pag-calculate sa data na imong na-collect. A LIMS should be capable of performing and automating any calculations that are used in the testing process to provide quantitative results. So, as what I've said earlier, nga ang LIMS is ga-support siya sa modern laboratories operation. That's why, importante jud na capable siya sa pag-perform and automate any calculations para makahatag siya og quantitative results. And if we will say quantitative result, this is an outcome or conclusion that can be arrived at by measurement. Calculations are used to determine analysis results by applying a formula to dependent results and user-defined interim fields. The results for analysis set up with a calculation cannot be entered directly, so the LIMS calculates it as soon as all dependent results are available. Calculations are maintained in the LIMS setup by authorized lab managers, in which their correct execution can also be tested. Saved calculations are then available to be selected when configuring methods and individual analysis services. The final numbers depend on many previous inputs such as dilution factor calculations, percentage conversions, mass densities, and unit dosage weights. So the final numbers depend on many previous inputs like dilution factor calculations. The dilution factor or dilution ratio is the notation used to express how much of the original stock solution is present in the total solution after dilution. Percentage conversions. Converting from a decimal to a percentage is done by multiplying the decimal value by 100 and adding percent. Mass density. It is a representation of the amount of mass, or the number of particles of a substance, material, or object in relation to the space. Unit dosage weights. The body weight used for calculating the appropriate dosage of a medication for those whose weight exceeds the usual average range. For the next slides, we have here Mr. Camarin to explain it to you.
Good day everyone, my name is Gino Dave A. Camarin and I am the next reporter for Statistical Analysis and Calculations. So, additional outputs may need to be processed further, such as conversion of total potential THC and CBD based on a theoretical decarbosylation factor of 0.877 to account for the loss of carbon dioxide. The main pharmacological cannabinoids are THC and CBD. However, THC also includes undesirable psychoactive effects. The decarbosylation process converts the naturally occurring acidic forms of cannabinoids such as cannabidiolic acid, or what we call CBDA, and tetrahydrocannabinolic acid to their more active neutral forms known as cannabidiol and tetracannabinol. The major active components of cannabis sativa are cannabinoids. They are produced via decarbosylation of their acid equivalents. So, two different kinetic models were used to fit the experimental data and to predict the optimum decarbosylation conditions to maximize the THC or CBD concentration. As you can see in the picture, decarbosylation was converted. This reaction follows first-order kinetics with THCA showing the fastest decarbosylation rate. In all cases, a significant loss of neutral cannabinoids was observed at elevated temperatures and reaction times, although this can be minimized in the absence of oxygen. Often types of calculations to perform are dependent on the requirements of the client. So it is important to maintain appropriate lines of communication between staff. So let's proceed to theoretical calculations. Theoretical calculations utilized to investigate how the rate determining stages of decarbosylation processes are influenced by distance annulated ring or pendant substituent. So, in the meaning, it is used to investigate how the rate determining of stages of the decarbosylation. So the next one is uncatalyzed ketoenol tautomerization. It is discovered to be highly sluggish in both circumstances, with CBDA having a tenfold preferences. So that is all, and thank you for listening.
Hello, I am Jericho Anyabiaza, and I will be discussing to you the laboratory data and litigation. So now let's proceed to laboratory data and litigation. So it says here that laboratory data consist of clinical laboratory data and associated person-specific data and other information related to clinical laboratory services, Quest Diagnostic, or their affiliates. While the litigation naman, it refers to a process of resolving disputes by filing or answering a complaint through a public court system. Kasi when it comes to arguments, most of the cases really needs to have or provide a laboratory results to show analytical data and results able to support what you are or what they are fighting for. So laboratory data has historically been the tipping point in both civil and regulatory litigation. So when you say litigation, in Tagalog, it is paglilitis. So many times, the basis of litigation is in claims that are groundless if the data cannot be used in court. So the cannabis industry has seen early litigation regarding label claims and stolen product intellectual property for these cases. So to prove or defend against a false label claim sa inyong industry or any industry, so the data that is demonstrate the truth must be deemed or admissible, or it means valid or acceptable in the court by both parties and presiding judge. So, an experienced attorney will hire a data validation or data validator expert to try to have the data deemed admissible or have the data evidence thrown out as appropriate to the case. So the data validation activities includes the review and evaluation of the following elements as stated in the ICH and AOAC International guidelines. So now we have the International Council of Harmonization or ICH. So this brings together the medicine's regulatory authorities and pharmaceutical industry around the world and aims to achieve harmonization worldwide that develop for safe, effective, and high-quality medicines in most resource-efficient manner. So it enable for them to achieve their goal. They have to develop guidelines and techniques that requires enable for them to achieve their goals. And here the other one is the Association of Official Agricultural Chemists or AOAC International. So AOAC International is a non-profit scientific association with headquarters in Rockville, Maryland. So it was founded in 1884 as the Association of Official Agricultural Chemists, AOAC, and became AOAC International in 1991. So it aims to address emerging microbial threats to food safety, to deliver analytical solution to capability gaps in laboratory testing, and to develop standard for the use of cutting-edge diagnostic technologies. So here we have the guidelines. So first, we have the specificity. So specificity is the ability to assess unequivocally the analyte in the presence of components which may be expected to be present. So typically, this might include impurities, degradants, matrix, and etc. So when you say impurities, it is something to do, or it is ensures that all the analytical procedures performed allow an accurate statement to the content of impurities of an analyte. Example like related substance test, heavy metals, residual solvents, content, and etc. Next of the guidelines is the accuracy. So an accuracy is a property of a single measurement results and is influenced by both random and systematic errors. So it is therefore not included as a such in the method validation itself. So the accuracy of a measurement is result describes how close the result is to its true value and therefore includes the effect of both precision and trueness. So, in short, accuracy, it is something how close a measurement or attempt is to the actual or target value. So, I have an example here. Here we have a dart. So, as you can see here in the dart, 'di ba ang target natin dito sa dart is yung pinaka-center. So that is the value and that is the actual target that we are aiming for. So when you say accuracy, it is something to close a measurement or attempt its to actual target value. So as you can see here, most of the target is almost or close to the target value, which is the center. So that is accuracy. So now we have the precision. So the precision describes as a measure of the closeness degree of scatter. So between independent test results obtained under stipulated conditions, and stipulated conditions can be, example, repeatability, intermediate precision, or reproducibility. So it says here that precision is something to do with the closeness of the target or the closeness of the result. It means like repeatability. So it means the first trial until your third trial is the same with each other. So here, my example here is, as you can see, the first target is, it is far from the actual attempt, or the target value. So it is far, but on our second try, it's still close to our first try, and then our third try still close to the first try. So it simply show you or give you a hint that this is a precision, because a precision again refers to how consistent or results are regardless how close to the true value they are. So that's it. So I have here an example of accuracy and precision. So as you can see here, the arrow is placing the near the target value. So it is accurate and precise. Why it is called precise? Because it is close with each other. It has a consistent target, or it has a consistent aim. So they are accurate, precise, since it is near to the actual or near to the attempt value, and it has a consistent target or endpoint sa dart. And next here we have not accurate but precise. Not accurate, precise. So the reason why it is called not accurate, because as I have explained earlier, you can only call it accurate if it is close to the actual value or the attempt value. So it is called precise since the arrow or the target o ang bala na ating ginamit ay nakatama sa parehong lugar. So it has a consistency. So it is a precise. So we have again here accurate, not precise. So why can you say that it is accurate and not precise? So if you know the explanation, then comment down below. Char. So next is not accurate, not precise. So again, I hope you have learned. So I'm not going to explain this because I hope you really understand the accuracy and precision. So now let's move to repeatability. So repeatability expresses the precision under the same operating condition over a short interval of time. Repeatably is also termed intra-assay precision. So, diba, I have already explained to you earlier or recently the repeatability and linearity. So the linearity of an analytical procedure is its ability within a given range to obtain test results which are directly proportional to concentration or the amount of analyte in the sample. And next, we have limit of detection or LOD. So the detection limit of an individual analytical procedure is the lowest amount of analyte in a sample which can be detected but not necessarily quantitated as an exact value. So next, we have a limit of quantification. So, limit of quantification, the quantification limit of an individual analytical procedure is the lowest. So, lowest amount of analyte in a sample which can be quantitatively determined with suitable precision and accuracy. So, the quantitation limit is a parameter of quantitative assays for low levels of compounds in sample matrix, and it's used particularly for the determination of impurities and other degradant products. And next, we have range. So the range of an analytical procedure is the interval between the upper and lower concentration of analyte in the sample, including this concentration for which it has been demonstrated that the analytical procedure has a suitable level of precision, accuracy, and linearity. Next is rudeness and robustness. So, rudeness and robustness, it is a degree of reproducibility of test results obtained by the analysis of the same sample under a variety of conditions, such as different laboratories, different analysis, different instruments, different lots of reagents, different elapsed assay times, different assay temperatures, different days, etc. And the robustness is the reliability of an analysis with respect to deliberate variations in the method parameters. So that's it for the guidelines. To continue the discussion, here is Chris Zinner-Holve.
So hi guys, my name is Chris Zinner B. Holve. I'm from BSMT 1B, so you guys may know me. Laboratory and data litigation. So let's continue that topic. But first, let's recap what is LIMS or Laboratory Information Management System. So LIMS is a laboratory management information system, helps labs to plan data management effectively, accelerate operation, and execute different business decisions. It also helps in generating rapid reports and control and audit trails along with a timestamp and date. So the importance of LMS: it reduces clerical tasks or work, better evaluation of workload, faster communication, improve of information given to the clinician, adaptive reference values, interpretations, comments, improve retrieval operation, and faster billing. Next is uses of LMS. First, it protects laboratory data. By safeguarding the data or the laboratory data, it provides various solutions designed to boost productivity and safety. So let's say, for example, LMS is like a police officer who would take a risk to help you or to protect you by foreign invaders for someone who tries to get your data, laboratory data. So that's the same goes with LMS. So also, LMS is able to house data generated in a way that is fully trackable and traceable. So LIMS can store data in a detailed and accurate, while it can be traced or tracked easily. So let's say, for example, have you watched the movie Ron Goes Wrong or Gone Wrong? It's all about the robot. All the robot in the movie was programmed to each children, and the robot knows everything in the kid who owns it. Same goes on LMS. It existed to know everything that is related to what is being programmed in the system. So an LMS provides detailed and accurate records for each sample and store it securely, thus reducing the chance that data can get lost or mixed up, since it moves between workers and departments. As you record the initial sample, the system will make a detailed records that outlines who recorded the samples. Next is LIMS also ensure that a rise dispute between clients and laboratory is documented properly and settle the case in the court law. So when the argument happens inside the laboratory, between the laboratory and the client, the LIMS insert and records every second in a detailed manner. And in order to settle the argument, the case must be on the court law to properly settle it. So as you can see here, there's a diagram here saying that LIMS advantages. So first, advantages of LIMS is workflow automation, real-time tracking and time saving, improved data quality, meets regulatory compliance, interface with instruments, and improved turnaround times. So next is processes on other context. Pesticide. And things like pesticide, this will go through a lot of process in all laboratory quality control or QC, and it will continue on calibration verifications in CCVS to ensure the instrument was properly functioning. It should pass all the criteria. So you can clearly understand what does it mean. So I'll just cite for an example. So for example, let's say a toy gun. So let's say, for example, this is a toy gun. So before it will be released in the public, it should pass a lot of requirements or achieve all the requirements it needs, since it will go to someone's hand. It will go a lot of experiment or testing to ensure the quality of the item. So in order for you to have this, it will go through a lot of processes, testings, experiments to ensure the quality of the item. So first, let's define quality control. So what is quality control? Quality control, or QC, is a procedure or set of procedures intended to ensure that a manufactured product or performed service adheres to a defined set of quality criteria, or meets the requirements of the clients or QC is a similar to but not identical to quality assurance or QA. So what is quality control in laboratory? Quality control is one of the most important impacts on laboratory testing. It ensures both precision and accuracy of sample results. Laboratory quality control is designed to detect, reduce, and correct deficiencies in a laboratory's internal analytical process prior to the release of the results, in order to improve the quality of the results reported in the laboratory. So as you can see here, there's pesticides here. A bygone is very common. Roundup is a, I guess Roundup is a agriculture pesticide. I don't really know. So next is this question widely used or commonly used in the court case. Is did the process definitively prove that the pesticide is in the questions was present? Or how did you prove this? How did you prove this? How would you prove this? This would require the lab can source the sample's instrument file and demonstrate that both the parent ions of the compound in question was present, along with the qualifying ions or mass transitions to confirm the compound in questions. Since when the lab result was possibly handed, in the most cases in this question was in the most court cases, this question was usually asked: is did the process definitively prove that the pesticide in the question was present? Or how would you prove this? This can be answerable based on the experiment, and the laboratory is one of the best sources you have of the experiment. It has all the samples instruments file, and also wait for a minute, and also shows the parent ions was present with the qualification of ions or mass transitions to confirm the compound in questions. So next is if the question come up on the possibility and mishandled by the lab, causing to contamination of the sample. This appear the chain custody and audit trails really benefit the defendant data. If it appeared that the sample exchanged hand and the person who handled the sample for each part of the analysis shows an accurate timeline as when contamination was held and may have occurred. So when the lab result was possibly handed in a bad hand, this might end up into a disaster, since it will cause a contamination of the sample. Same goes with the power. Yeah, if it lands in the bad hand, then it will surely end up used in bad doings. So first, let's define audit trails for you guys to know. Audit trail is a date and timestamp sequential records of the history and detailed around a financial transaction, work event, product development phase, or financial ledger entry. So next, let's define chain custody. So chain custody is a tracking record beginning with detailed scene notes that describe where the evidence was received or collected. Collection techniques, preservation, packaging, transportation, stores, and creation of the inventory list are all part of the process used establishing the chain custody. So if it let's go back to the PPT. If it appears that the sample exchange hand and the person who handled the sample for each part of the analysis shows an accurate timeline as to when contamination may have occurred. So if it fell on the right hand, the analysis came up accurate in terms of timeline, and also contamination occurred then it is safe to say that the pesticide is in good it is good to produce in the public or acquired by a consumer. So here's my references on my topic. So thank you guys for listening. So that's the end of our discussion about statistical analysis and calculation and laboratory and data litigation. Again, we are the group 15 and 16. Thank you guys and have a great day. Bye bye.